Shall we start?
Okay, we are starting. Today we have arranged a guest speaker session with Sir Shahid Ashraf. He is PhD scholar at University of Kebangsaan, Malaysia. He has so many. He has a vast experience in teaching in various universities such as LAD. He also taught with us at FAST University. Currently, he is at DHS Sofa University. So over to you, Sir Ashraf.
Thank you so much, Safar, and thanks to the FAST management of FAST that they have given me this honor to present the working about the a guest speaker session for the linear algebra. Um, this is not like for the students. Sometimes whenever they are studying linear algebra or any course of the mathematics, the first question that comes in their mind is like, what are the applications of the linear algebra, or what are the motivations that they have to study the mathematics courses. So the teacher that are teaching in a regular way in their semester sometimes declare them some of the applications. Sometimes they taught them some of the applications, but due to the limitation of the time, I understand that like all the application cannot be taught in one class. Maybe if I thoroughly explain you all the application of this session, like the application that we are going to discuss, as just for the motivation that where the linear algebra is applicable. So this will become a session for maybe more than 12 hours. So explanation of the methods or the application is difficult, like all the application. And since linear algebra is one of the basic course that is applied in so many parts, like let's start it with like what is linear algebra. All of you know that the equations, the dealing with the equations or the set of system of linear equations, the variables in which in the matrices involved, set of vectors are involved. We prefer to work with the matrices just because of the simplicity. Like if you have 9 equation or 10 equations, you can consider like if you are following the elimination method for the solution of these equations. So this will be a headache. Like the first equation is when you separate the first variable, it will be equal to like on the other hand side, like it will be depending on 8 other variables. So this will be a headache if you substitute all the variables in all 9 equations. So controlling of the variable is so much problematic. So it's better to work with the matrices, or matrices is basically the set of vectors. I have described only 2 equations of system of linear equation, and this equation can be extracted or continued to the n form, like n equations, whatever the number of equations are. This is basic definition of the linear algebra. Without wasting of time, since I have only 1 hour to complete this session, without wasting of time, let's go to the importance of linear algebra. Let's say the first importance is computer graphics. Whenever we are describing the computer graphics through any simulation or any CAD software, so this CAD software cannot be, or simulation cannot be worked with the continuous form of the data. Like we cannot describe the continuous form in even describing a line. Like if you describe a line that is made by 2 points, 2 points can make a line. So between these 2 points, we have an infinite number of points. So between 0 and 1, let's say between 0 and 1, if we have a step size of 0.1, then we'll have 10 points, like 0.1, 0.2, 0.3, and so on. But you know that if I consider it as a continuous way, like 0 and 0.1 has also an infinite number of points. So we cannot continue with the infinite number of points, and for that simulation we need just discretization. And discretization is basically the working of equations or the system of linear equations, so that the this computer graphics can be described in a way that can be stored in my memory also. You can consider also it like if you have infinite number of points, you cannot store it in a, memory of the computer. Since the memory is not infinite, we have a limited memory for computation and for working. Similarly, the second application is like you can consider it as like web page ranking. We'll see a bit like how web page is working, or how any Google search engine, or any search engine is working with that web page ranking. Similarly, the graph theory. Graph theory is also very important in while you're performing the linear programming, or linear programming have so many tasks. Like either you have the assignment problem, or you want to optimize the or you are dealing with the transportation and you want to optimize the transportation cost and everything. Like if you wanna scheduling a things or allocation of resources in this way. So this graph theory will will help you a lot. So in information technology, we also deal with the graph theory, like a flow of computation, and everything is described by the graphs. And this graph theory is also can be converted to a matrices. And these matrices are basically the form of set of vectors and so on, a part of the linear algebra. Similarly, we'll be discussing cryptography, a part of the cryptography. Cryptography is like converting a message or any text to ciphertext or a coded text first, and then this coded text can be deciphered or decode to the original text. So we have a key of like encryption. This key is stored. This key is unique and stored in some part. Like if someone is sending me a message, only me is the person who knows how to decrypt it, and the person is encrypting the same. And the person is basically using my decryption key or the inverse of the decryption key as an encryption. So this will be the part of the cryptography that we'll have to discuss in this session, inshallah. Network model is also like, let's say we have a university and we have two departments, like mathematics department and computer science department. Both are using some of the resources, like both are using library, both are using computer lab, and this can be a network. They all are connected in a network in a form of a network. So this can be a DBMS network model. We'll discuss it later, like how will it work, like in which way we can describe this network model in the form of linear equations, or in a form of a matrices or set of vectors. Similarly, the linear programming, as I said, the linear programming is basically working with like you can say we have three forms of the solution, or three forms of the method in the linear programming: graphical method, matrix method, and third method was slipped off my mind. Like, but there are three methods for the linear programming. These linear programming was extensively used in the World War II also. This linear programming was used by the person who invented, like Danzig, I guess. If I'm wrong, Sir Basit, please correct me. Like Danzig is the person who was invented this linear programming in 1913, and this linear programming was extensively used in World War II to to deal with the transportation of the government, to deal with the allocation, to deal with the scheduling, deployment of the persons, like armed persons, and so on. Like in this sort of way, so that the cost is minimized. So the transportation cost, not only the transportation cost, also the working with the like optimization and feasibility solution of the available resources. Like if you have let's say the food for 30 days, this food for the 30 days can be sent directly to the in a first day to the like troop or something. But this can be used, or this can be optimized by sending how much food can be sent in a one way to minimize the cost and minimize the transportation cost and everything. Like this sort of restriction, this sort of availability, or using the resources is deal with the linear programming in World War II also. Similarly, the principal component analysis is also one of the like basic thing that is used by the computer science students who are dealing with the to analyze which component has to be described, like which while searching in a web page, you can have the principal component analysis of that web page. Let's say this is computer graphics, the first application that we have described, like computer graphics. This is a gray scale of the image, and you can see like the resolution of this image is not so clear. But this the part that is highlighted here is basically can be shown or zoom in this way, like the red circle, the red rectangular highlighted area. And this red rectangular highlighted area is basically a set of the matrices, like a set of the vectors that is represented by this matrix. So you can try it on a MATLAB. Let's say a MATLAB command you can just write any matrix, like say A matrix is 356 and 4. The second row of this matrix is -1, 34, and 50. The semicolon sign is used for the changing of the row. So -1, 34, 50, and the semicolon again 188 and 23. If you just write this matrix or any other matrix that you like whatever the number that you have described to the matrix, either this is 3 by 3 matrix or 5 by 8 matrix or any other matrix. We have a resolution like the resolution of 1028 by 728. Like this is basically the number of the elements that is present in that is available in that matrix. I cannot show that the big matrix here in one page, obviously. So that's why I just pick a 3 by 3 matrix, so that you can have idea like how this matrix represent as an image. Like this image sc command is basically used in MATLAB to show the matrix into an image. What we have done in the previous slide, like this is an image that is transformed to a matrix. Image can also be transformed to a matrix by using the imread command in the MATLAB. You can see, and you can see the help of the document that is available in the MATLAB. But if you want to describe some matrix in an image form, so this matrix is represented by this image. Now you can see here we have different colors, we have different sort of the pixels. You can see here this matrix command is now being used in a computer graphics. They are using like the old picture that was previously captured in a gray scale now can be converted to a color scale, can be converted to a color form by this sort of the things. Like you are just first extracting the matrix of that particular grayscale image, and then that matrix of the grayscale image is reconverted to the color form. So the color form of this image is basically can be shown. So this is basically the transformation that is used in the graphics model or computer graphics. Graph theory, similarly, the second application that we have to study or we have to be motivated, like graph theory. Graph theory is basically a representation, you can say, like every network can be expressed mathematically in a matrix form. And this matrix form is, we have two matrix form in the graph theory. Like maybe we have adjacency matrix, or maybe we are describing the age of the matrix. Now you can see in this picture also, like we have A, B, C, D, E, and F are the nodes of the are the nodes of this graph, and we have ages also, like A to B is one of the age of the of this graph, and similarly A to C is another age of this graph, and similarly A to F, and so on. These are the ages of the matrix. So this graph or this flow of the information can also be described in a matrix form, and this matrix is basically known as adjacency matrix. Yeah, this matrix can be either a directed matrix only, like we are describing of this graph. Describe, like if you want to go, if you are considering this graph as a transportation cost or transportation problem, like if a point, from a point if you start and you want to go to b point, the transportation cost is 40 rupees, let's say. And if you want to start with A point and you want to go to C point, then this transportation cost is 50 rupees. So this is basically the weighted way of describing the numerical value of this ages. So we have three forms of graph. We'll see it in the next slide. So the numerical value is described by this, like we can convert the graph into a numerical value. The third point is like by this representation, what we want to like highlight, or what we will get by this representation. We can evaluate the degree of the graph that is used by, like, that can be described, or that can be evaluated by using the basic concept of the linear algebra. I'll describe it in the next slide, inshallah. And similarly, the centralities is like which part is the most common thing, which part is the most important thing in this graph. So this can be described by this sort of things. Like graph theory, let's say we have these nodes as described as a V, A, B, C, D, E, F. We have also ages. Like in this graph, we have different ages, like A to B, A to C is also described. A to C and C to A are both are equal. Like if you go from A to C or C to A, the time will be same, that everything is same. Although we are ignoring so many constraints here, we are ignoring so many things here. But for a graph, we can say if you want to perform a task from A to B, and you want to perform a task from B to A, the time and everything will be same. Similarly, we have A to C, another age, A to E is another age, A to F is another age. You can see like B to C is another age, C to E, C to D, and there is no age for the C to F, since C is not connected directly to the F. Similarly, E is connected with A, EA is previously described as AE. So E is connected with F, and so on. DE is previously described. So in this way, the graph theory have either a nodes, we have nodes A, B, C, D, E, F, and we have ages like A, B, A, C, and so on. So let's say adjacency matrix. What I was telling you, like how you can describe this graph in a form of numbers, in a form of numerical values. So in a form of numerical values, if we have described like adjacency matrix is basically a translation of a matrix of V square. Like we have to multiply, we have to consider only V with V. So you can see here in a column, I have just described A, B, C, D, E, F, and these are the nodes of the graph. And similarly, in the row, I'm also describing the A, B, C, D, E, F. They are also the graph. Now you can see here, like A cannot be connected with A. So A to A is 0, B to B is 0, C to C is 0. This column is completely 0. Yeah. So all A to A, B to B, C to C, and D to D, they all are not connecting with their self. Although the cyclic graph can also, in a way, like if some person have started the thing at one point, it can be end by by that point. But for the graph theory, we have to describe it like the person has to go first in this way and then come back. Like let's say if you are going, if you're coming from your home to a university and then going back to the home, this is cyclic. So you can say the node A is again reached to the node A, but node A has different points also. All like you are coming from the node A to node B, like from home to university and then going back. That is not possible that you are at home and you are saying I just go somewhere and after coming back I'm on the same point. Like whenever you say you go somewhere, that means you have changed the position, you have changed the node. So that's why A to A is 0, B to B is 0, and similarly and so on. Like you can see here, A to B is given a numerical value equal to 1. A to C is also given a numerical value equal to 1. A to E is also given numerical value equal to 1. A to D is not directly connected. So we have described the value as 0 here. So this is the way that we are describing the adjacency matrix, that we have converted this graph into a matrix form. Similarly, we have another matrix, incidence matrix. Incidence matrix is like which incidence or which edges you want to consider with respect to the V, with respect to the node. Now you can see here, I've ignored the one of the edge here, especially AE. AE is not described in the edge. So incidence is basically, I want to check whether the nodes are connected with these incidents or not. Like with AB, AC, AF, BC, and all of them. I've just ignored AE here. So AE is like while you can see in a graph what will happen if there is a VIP movement at SRFSL or somewhere. So we have blocked this AE route. We have a route. We have this route. AE route is available, but for now this is blocked. Now, what will happen to the other part of the transportation, or what will happen with the car and traffic and system? So I've just ignored this route. This route is blocked here. So you are just describing in a way like A is connected to like B, A is connected to C, and so on. Like these nodes are connected to in this way in edges. So this is the way of describing the incidence matrix. Like it translates the matrix of the size of V by A. So this is a conversion of we have two sort of matrices like adjacency matrix in which the V is connected with V, like nodes are connected with nodes, and we have incidence matrix like V or the nodes are connected with the edges of the graph. So the three common model for our graphs are undirected. Since we have see here, like this is undirected matrices. So undirected matrices are like we can go from A to B or we can go from B to A. So this is undirected. We haven't described the direction of the matrix here. This sort of the matrices are like this sort of the graphs are known as undirected graphs. Similarly, we have directed graphs also. Like there is no way out to come from B to A. Once you have moved from A to B, now there is no way to come back from B to A. You have to go on like the B to either you have to go from B to C, either you have to go from B to D, B to F, B to G. There is no way for B to E also. This is a way that we are describing a directed graph. So similarly, we have the weighted graph also. Like see here, the distance between A to B is like you can see, you can measure here, like let's say this is 1 centimeter or anything. The distance between B to G is so much. So we are not considering the distance, we are just saying all the values are 1. Like from A to B we have given 1, from B to G and B to C we have given the value, numerical value 1. So this is not weighted. But in this graph you can see we have described the weighted way of describing, like if you want to go from A to F, the cost will be like 16. Or if you want to come from F to A, the cost will be 16. If you want to go from A to E, the cost will be 12. So if you want to come from E to A, the cost will be 12. So in this way, we have described this weighted graph. The weighted graph is described in this way, and like weighted graph can also be a degree. There is some terminologies that is coming here, like degree, out of the degree, and degree. Degree out of the degree. Out of the degree is like um, when you have no choice, like no choice of coming back. So whatever the way that you are performing is basically out of the degree. The age, let's say you are describing your graph, your age and your achievements in directed way. That you have, let's say you say I got A plus in my matriculation, I got A plus in my inter, and then so on. I'm describing my achievements, my life in a directed way. Can I go back in this way? Like this is not possible. So I'm out of the degree. Like this is done. This is done. I cannot go back. I cannot go back in a past. Although in the movies you can see so many things, like especially the hero can go in a past and correct all the things and come back to the future again, so that, or maybe he can go to the future and then come back in a past to enjoy the current moment. But this is not possible in a mathematical way. Like mathematical way can be directed, and this is out degree. This is out degree centralized. Graph theory can also be applied to the flow, to describe the flow of computation, or to represent the network of communication. The network of communication, like let's say we have three forms of the network of communication, or we have many forms of the network of communication. The picture is showing only the basic network of communication. We have three forms of the basic form of the network of communication, like chain network, wheel network, and all channels. In a chain, like consider Sometimes it happens, like if you say some person to say to another person, like I'm saying this word, these words to you, but you have to describe the same words to the another person. This is form of the chain. Or maybe in a reverse direction, apart from the joke, like whenever you say don't tell anyone, what will happen? The next person will have to definitely tell to someone else, and this will continue to like don't tell anyone. This is in between you and me only, but don't go for describing it to another person. But what will happen? Like it will be continued. This is basically a form of the chain, like a way of communication. You are describing this sort of communication. You are following this network for the communication. The wheel is like a person is in any institution we have the head of the department. You can see the head of the department, and this sort of the network of communication through the head of the department is like a wheel. Like the head of the department is giving the instruction to all of their subordinates, and these subordinates are also replying to the head of the department. Similarly, this is the wheel way of communication. Maybe these two can also be communicate with each other, but this communication is will not be considered as official way, or a significant way. Whatever the instruction is given by the, let's say, whatever the instruction is given by the head, and whatever the feelings of the employees are not meaningful. So in this way, we have a network of communication in a chain, either in chain or in wheel or in all channel. Like in a friends of circle, we are following all channels of the network of communication. Like on a WhatsApp, you have a group, like a friends group, and you can see here the WhatsApp is like you have the admin over there, but still everyone can talk to anyone. Like everyone is talking with each other and so on. So in this way, the channel is described as a network of communication, and this network, all these network that I am describing, can be converted to this matrices, like adjacency matrices, so that we can find the degree, we can find the centralized way, we can find the after converting it to a matrices, we can describe it to like, let's say, we can optimize the way of thinking, we can optimize the we can optimize the transportation cost. Let's say this is not only the channel or the network of communication for only friends, this is official channel. So these channels can be optimized in this way. To represent a data organization, is it's also the part of the graph theory. Like the hierarchy is also mentioned in this way. Like the first thing, let's say for the institute, you can for the university, you can understand it very well. Like the first is chancellor, and after the chancellor we have vice chancellor, and after the vice chancellor we have either a director or deans, and then deans from the head of the department, and then the faculty. Or maybe the fast as the following the another way, like that you have directors and then head of the department. And so to represent the data, to represent the organization data in some manner, you can use the graph theory. And also, like for the flow of computation, every person knows that for describing the algorithm, from where to start, what to process, and so on. I haven't described it here. Like flow of computation is so common thing. In a first point that I write, like flow of computation, you are describing it in a very well way. From the first semester of your studies in a computer science or in IT or any field like AI or anything, you know the flow of computation, like from where to start, what to process, and where to end. So this loop can be described by the graphical. This loop is basically described by the graph theory. The fourth point is like to find the shortest path in a road. Like you know this point, like Dijkstra algorithm. Dijkstra algorithm is one of the algorithms that is used by the Google Map also. Uh, this is I've opened this. I've answered this question. Basically, what do you think how Google Map works? The Google Map works with two sort of the algorithm. One of the algorithm is Dijkstra algorithm, and another is A-steric algorithm. There is a bit difference between these two algorithms, although this algorithm is used only for finding the shortest path of the method. Dijkstra algorithm is currently using by the Google Map when you have to go from one point to another point. Just you have to start from one point, and you have to go from the another. You have to reach to the end point, to the next last destination. You can say. So this is basically the following of the Dijkstra algorithm. But if you say like I'm coming from my home, first I'll go to pick my friend, and then we'll go to the university. So what will be the best way? What will be the shortest way of describing this map? So this will be described by a steric algorithm. There is a minor difference between these two, but this is only one difference. I have described it here. Like for this sort of algorithm, you're using the asterisk algorithm, but this is basically the how the Google map is working. So the I have also showing the picture of the FAST University, the Karachi campus, that is going to the Mali campus. Like let's say we have so many nodes here. You can see the FAST University. From the FAST University, you have to go at this point first, and then like Qaidabad, and then go on till Shah Faisal, and then this. In this way, you'll reach to your destination like Mali cantonment. But you can see here that by following this way, it will take 38 minutes, right? But if you follow the another way, like for any reason, if you follow the another way, this will take 39 minutes. If you follow the another way, like it will take 52 minutes. So these different ways, these different optimized ways are basically described by the asteric algorithm, while the shortest path is described by the Dijkstra algorithm. So this is basically the use of these two algorithms, and these two algorithms are basically the representation of the matrices, the representation of the linear algebra, and the transportation cost or optimization through the linear programming, basically. So linear programming will be the your course in some of the when maybe in 3 or 4 semester, or after some semesters you will study the linear programming course also. And you'll see how we can reduce, how we can find the shortest path of this graph theory. Page ranking of the Google, like this is somehow the page ranking. When someone search for some pages, you'll see like if I search anything, the Google will describe me, or Google will show me so many pages. Like you can study the same thing from this point, you can study the same page, same thing from this point. But at the top position, it shows the web page by using the let's say linear programming, or you can say the page ranking. Google has stored the page ranking in its memory, like how the people are working, how they are spending their time on that page. So spending on the time on that page, and describing that, like how to give the weightage of that page. Let's say if I search a song on a Google, so this song can be listened by so many things. You can see like so many things, or so many websites, like either the YouTube or what. Or I don't recall any other website. Sorry for that. Like it's being a long. Like I haven't searched this sort of thing. Like for the videos, we are only watching the videos through the YouTube. So maybe any other website, Daily Motion, like Daily Motion in a way. So, but this song is basically if some person is most of us are using YouTube. So whenever you write on Google for anything, it will first show you the results from the YouTube, and then will show the results from the another website. So this is the way of like page ranking. If you search any word, if you search anything, any video or anything. Um, let's see. Let's consider a simple example how it works. Although this is the maybe the last topic, or the last topic of this course, like linear algebra, you have studied, either you have studied or not, or maybe you will study in the future, like the power method. But how it works, we'll see. Like let's suppose there are 4 person A, B, C, D, and some of them know each other and consider themselves as a friend. Like they are considering themselves as a friend. If I say, let's say a matrix T is described in a way like A cannot be friend of himself. Obviously, that's why I'm giving 0 to him. But A is considered B, C, and D as his friends. So the equal weightage is given to all of the friends, like 1 upon 3, 1 upon 3, and 1 upon 3, so that the result will be 1. The total result will be 100%, that A has consumed its vacancy for the friends. Similarly, B has only two friends. B has only two friends, as like in a column. You have to see in a column now. B has only two friends, like C and D. So the weightage is given in a way like half and half. Similarly, the C has only also has two friends, A and D, and D is having only one friend, A. Okay, so this is the way that the matrix is described. Like four persons know each other, and they consider themselves as a friend. Like, let's say I've described this point. So let's say the raw sum. Raw sum is like how much how much people like A, or how many people wants to be friends with A. So you can find like one and half. Since the C has given a weightage to half to A, and the D is given weightage 1, like D is sufficient with A. Like D is saying like A is sufficient for me as a friendship. I don't want any other friend. So A is sufficient for me. So A got the highest point. Like A got so much point by this way, like 1 plus half. So the raw sum, or the raw score, you can say the friend score, is 3 by 2. Raw score or friend score of person. A person is 3 upon 2. Similarly, you can find the raw sum of the second matrix or second person, like the B is 1 upon 3. Like B से सिर्फ 1/3% चांसेस है कि लोग फ्रेंडशिप करना चाहते हैं. इसी तरीके से C has 5/6, and similarly D is 4/3. So you can see here there is a weightage for being a friend. Like A is so much friendly, like it got the points like 3 divided by 2. And similarly, the fraction is showing you the results are raw sum, and this is raw sum that you have studied in your linear algebra course also. That is describing the friend score here. Similarly, you can consider A, B, C, D as the web pages. Like let's say if A, B, C, D are 4 web pages, that is showing the result of anything, any incidence. So if some person spend, let's say, on one page half hours, so it will be stored in a Google like half hour has been spent on this website. Let's say another person also spent the same time, same number of time on that same page, let's say for 24 hours. So 24 hours is also added to that web page. So it will be continued in a way like the score of the web will be becoming higher and higher. So whenever you search from the Google, it will show you the page. It will show you the page in this way. Like it will raise the ranking of that page, and this ranking by raising the ranking of that page, whenever the first person, whenever any person who is searching something for the first time will be shown the results by that page. So this is basically the data that is stored previously by this way. So this is basically how the page ranking is working. And the page ranking can also be described like in a power method. Suppose we want to find like who is our real friend. So for that you can use the power method. Maybe you have studied this power method or not, or maybe you'll study this power method in the future, either in this course or maybe in another course. And you can use the iterative method for that, for finding the like I have a limited time, since I have only 15 minutes left, and now there is a lot of presentation, and there are a lot of pages that has to be described now. But still, I cannot go with describing the power method right now. But the power method, you'll study, either you have studied this method or you will study this method. You can find it like which friend is which one is our real friend. The point that is given equal, like A has described in this matrix, you can see the A has given equal weightage to all of them. But by B, the score of the B is so low. So B cannot be the real friend of A. Maybe the real friend of A is D, or this can be given as a priority. So this power method can be used for finding the real friend or something. How it works, it will give you the power method is described in this slide. And basically, it will give you the dominant eigenvalues and corresponding eigenvectors. I hope you have studied this, the eigenvalues portion. Eigenvalues is basically not only for the power matrix or for only the page ranking. Eigenvalues can also be used for, let's say, the face recognition. The face recognition in a like in a mobile, you can have the face recognition log or something. How it works, like let's say uh, you have once stored your face recognition, and then what is going to happen with that face, like especially with the female, don't be offensive, but this is just for the understanding. Like for the females, when they dress up and they make up their faces, and they again use the face recognition on a mobile phone, what will happen? It will definitely recognize it. Why? Since it's not using the surface value or the surface color of the face. Okay, it's only taking the end point or the eigenvalues of the faces. So at different nodes we have different eigenvalues. Let's say for the cheek of this point we have some eigenvalue, for the forehead we have some eigenvalue, for the nose we have some eigenvalues, and so on. So this will go on and something like in this way. And these eigenvalues are stored in a in your memory for the either for attendance or for unlocking the mobile phone. So this eigenvalues, if the eigenvalues, maximum number of eigenvalues is matched, or the greatest possible sum of the eigenvalues is matched, the mobile will be unlocked. So how it works? Similarly, you can consider it like this is not the like high security system. High security system is like they are working with the retina of the eye nowadays. They are not considering only the face recognition system for the security, or not also the like thumb impression, thumbprints, etc. So thumb prints, thumb impression, and like face recognition is now not the high security. The eye retina is basically the high security, and sometimes it happens like for the most high secure system, they have to give some drop of the blood also. Like DNA system is also used for the high security systems. Like while you're testing your God forbid if someone has a diabetic, but if someone is testing its his or her sugar, so one drop of the blood has to be given to that machine, and that machine will describe you the diabetic value or the sugar level of your blood. So this sort of way is also using nowadays. This sort of way is also using as a high security system. And these high security systems and that DNA, the values of the DNAs are basically stored as the eigenvalues. So this is the way how the web page is working. Let's move to the another application. Let's say the cryptography. Cryptography is like if someone is sending a message, hello, that is encrypted into Y6UW$I, and then this message is again decrypted by another person, and it will be seen as a hello to him. So how this cryptography is working? Encryption, like encryption is the process of like converting the readable message that can be easily read, is known as readable message to unreadable form. Like it transforms the readable message to unreadable form. Decryption is basically to reconvert the unreadable message to readable form. Similarly, we have original message or text that is known as plain text, and also we have encrypted message or text. This is known as ciphertext. Now you can see here in this picture, hello is basically the plain text, and Y6UW$I is basically the ciphertext. And this ciphertext is basically again converted through the decryption to a plain text. Okay, so this is the way that cryptography is working. Let's consider one example. Like this is most simple example that can be used for the cryptography, although the cryptography is not that simple. But let's say, for the sake of our understanding at this stage only, if we describe the number of and if we describe the number to this alphabets, like A is equal to 1, B is equal to 2, and up till Z is equals to 26. And then let's say, oh, there is another terminology that you have to understand, the modulo. Either we are using this modulo or we are not using this modulo. It's up to you. Uh, in the next example, in the example that is shown in the next slides, is without a modulo. But I can understand that modulo has to be described for the cryptography or encryption. Like modulo is described as like how we can find the remainder, or what will happen if we divide 15 modulo 3. 15 modulo 3 is not, I guess. Let me check, please. Oh, 15 modulo 3 is 0. I've just mistakenly, I guess it was written 1 here, but 15 modulo 3 is basically 0. Since the remainder is 0, I'll correct this type of mistake. But similarly, if you want to find this through the calculator, so in a calculator, you can go for your mod, and you have different things like to calculate. I have class with 991. So you can see here in this way, in the third option, it's base n. So in base n, while you select this base n model, if you describe this command, like you just have to write this command, a minus a divided by b multiplied by b. So this command will give you the result, what is the remainder of this thing. Like you can find you like for the remainder, you can use the synthetic division by जो हम बना के करते हैं ना, कार बना के, और वो हम solve कर रहे होते हैं, division कर रहे होते हैं, वो जो पूरी, like if you have 576 divided by 12, so this will take a lot of time to find the remainder, while you have to do it manually. For only finding the remainder, so for finding the remainder, you can use this command on a calculator directly. This will be a problem for the calculator, like for smaller values, you can find the modulo. But what will happen if you are using the greater values, like 56 power 26? So 56 power 26, for a large number, you cannot find it through the calculator directly. The calculator will not work with that, since 56 power 26 will be represented in an exponential form to you. So while the representing through an exponential form, the so many numbers have been ignored. Like if you have exponential form as 1.562356 exponent 26. Now what is this? Like the last value and the rest of all the numbers has been ignored as, or considered as 0. So basically, for the large number, you cannot find it directly. So I've made it a video here, and I'm just giving a reference. This will be useful for your understanding some of the machine algorithm also. Like this will be useful for you if you watch this video. I'm describing, like for the power, how it works, for the high power, how it works, how you can find the modulo for the high power, or the larger number. Similarly, let's move on to the encryption. I've just described the modulo, and I'm saying, like for this encryption, I'm not describing you. I'm not working with the modulo right now. So let's suppose in the encrypted matrix, this is already an encrypted matrix. That means I have used some key to my message to make this matrix as an encrypted one. So this is also mentioned here, can be converted by using the modulo to ciphertext, but I haven't used the modulo here. I'm saying this since 58 is not the number of the alphabet, but 58 is basically a cyclic of something, some alphabet. So this is just an encrypted matrix. You can use the Matlab or any other software for describing it. Like let's say the cipher matrix key that I have used was this one, 146 minus 5 4 3 4 7 8. This is the cipher matrix key. Like by this matrix key, I'm converting the original text to this matrix, this encrypted matrix. Okay. So what have to be convert to decipher this matrix or decipher what we can say, this text or this cipher text is like I have to just multiply the inverse of this cipher matrix key to the encrypted matrix. Okay, so the inverse is fine for like 146 minus 543. The inverse of this is minus 18 minus 11 divided by 87 and so on. This matrix is basically the inverse of the cipher matrix key. That inverse is used for decryption, for deciphering or decryption. For decryption, I'll just multiply this inverse matrix to our E matrix to get this one: 2, 8, 1, 14, 11, 0, and 25, 15, and 21. So going back to the numbers, like what they are describing, like you can see 28, 1, this, that is the first column, 14, 11, 0, and 25, 15, and 20 is basically showing you, thank you. So thank you is basically just for finishing this session. Like cryptography is basically used in this way. Like I can send you only this encrypted matrix as a cipher text, or this cipher text, this number can also have converted to a cipher text, like some cipher alphabets. So this is basically all that I have to discuss. This is only, there are some more applications like a regression line, interpolation, extrapolation that you have already discussed in so many times. Like regression line is also using the system of linear equations. Similarly, the interpolation, extrapolation for forecasting or anything else. Similarly, the discretization of the partial differential equation. This is literally a thing that is still everyone is doing it. For a partial differential equation or for any differential equation, you can say the differential equation is basically the continuous way or the continuous form of the function. So the continuous form of the function cannot be used in the computer. The computer have a limited amount of the memory, so we have to describe it through the discretized form in a like system of linear equation. We have to describe it in a system of linear equation. So this is one of the mesh that I have described here. Like I is here, j is here, so this point is basically I comma j. So going on, this will be I plus 1, this will be I plus 2, and so on. This will be j plus 1, and so on. So the distance between the step size between the x direction is del x, the step size between the y direction is, let's say, del y, but they both are equal to 1. That means I'm describing it a unit square grid here. This picture is basically taken from my current research. Like for a square cavity, I have done this like a triangular discretization has been done in this square cavity, and this square cavity has a hole, a cylinder inside, like in a center that is rotating. So this is my research topic right now for the fluid dynamics, and this you can see here, like the mesh points are described here. There are infinite. These are not infinite, obviously. These are only how much? 7,635 mesh points have been described here. So this is the description that is used by using the discretization of the partial differential equation, and this discretization is basically a part of that how you describe through the system of linear equations, nothing else. This discretization of mesh are described by using the system of linear equations. Similarly, the complementary function of higher order differential equation. If the students have already studied this course, like the differential equation, and they know about the complementary function, if they know, okay. If they don't know, like they'll in future they'll study the differential equation course, and you'll have the complementary function, like a into exponent of minus 3x plus b into exponent of 2x. If you have a root minus 3 and 2, you can have the complementary function as a into exponent of minus 3x, b into exponent of let me let's say if you have roots as minus 3 and 2, so the complementary function, if the dependent variable is y, so you have the complementary function as a into exponent of minus 3x plus b into exponent of 2x. So in this way, you're describing a basically, what is this? This is linear combination. linear combination of these all A and B. So linear combination is also used in a complement while describing the complementary function for higher order differential equation. This is all for my speech. If you have any question regarding any topic or anything, obviously you can consider it like for studying linear algebra, you have to be so for studying any mathematics course, you must know about some of the application. But you can consider like for all the teachers, like they have to cover the courses. You for the students, I want to suggest like if you want to see the application of that course, you have to study by yourself in your area. Like every student cannot study each and every application of the linear algebra. They can study what they like. Basically, if someone like cryptography, okay, then go for advanced study of the cryptography so that you can earn a required acquired knowledge of that particular subject area or any other field that I've been motivated to to study the linear algebra course. Thank you for this session. If you have any question, you can ask.
Students, if you have any question, you may ask. You may ask.
Don't be shy. You can ask any question with the related to the course. I guess they don't have any questions, sir. Either they have understand everything or they haven't understand a point.
एक
Is LA
chat
is
में
related to AI? Is LA is related to AI? AI is basically artificial intelligence. Artificial intelligence is a set of combination of so many subjects. You must understand the statistics. You must understand the computer programming. You must understand the machine learning and so on. So on. So this sort of things, machine learning. I'll show you one like. The second question, I'll answer the second question first. Let me continue to the first question. Like, in a first, what was I saying? Sorry, in artificial intelligence, you are using some learning, machine learning algorithms. So basically, in a machine learning, you have so many algorithms that have to be described. Like, let's say, if you wanna consider the human behavior, for describing the human behavior is considered as the most complex thing that can be studied. So like sometimes you feel by yourself. Let's consider yourself, like you have to store your own data. Like today आपने क्या क्या काम किया, आपका मूड कैसा रहा, what's your mood tomorrow, maybe due to some circumstances, due to something that is happening to you, your mood swings. Like there are so many things that is coming into your mind. Maybe you have pressure for the upcoming exam, upcoming quiz, or anything else. Like in this way you have so many things, so you can store a limited amount of the data into your computer, and that limited amount of the data can further be used as a machine learning. Okay. uh the second question was, I hope I answered the question. Arsal Javed, I hope I have answered the question. Why all the applications are related to discrete? Since you cannot store the continuous data or infinite data in your computer. Do you have the infinite memory in a computer? No one has an infinite memory in a computer. So even if the America has the most high tech parallel computing system right now, and that's why the America is considered himself to be the superpower. But America cannot claim that their memory is infinite. So these all things can be described in a discrete way. That, like, for an instance, like uh, for this instance, this has happened. So in this way, everything is discrete. You cannot even for numbers, you cannot count the like you can say we are recording this video, and for recording this video, if you say the recorded video is from 12 sorry, from 9 a.m. till 10 a.m. So what is happen here, like, can you have the video continuously described for every micro or nanoseconds? No, you cannot say that. If you are playing it, okay, you'll see the continuous video. But if you want to jump at some point, like, if I say you have to jump on the ninth minute, 29 second and 38 microsecond, 53 nanosecond, and so on, like so on, it will be continued. So you cannot describe it. You have stored the video in either the seconds or minutes only. But you have microseconds, you have nanoseconds, you have instances, but that doesn't mean that you have described it continuously. Mohammad Murtaza is asking, LA is the main core for making a smart AI machine where they could recognize their faces, generate emotions, and talking to us, obviously. So that's why for generating their faces and emotion and everything, you have to be what? Describe each and everything that you can consider. Like, for consideration or for storing, you can see, like, you cannot store your all emotions. If I say I have to store my all emotions, can I consider it? Like, for the emotions of towards the friends, I can describe it. Towards my family, I can describe it. Okay. What about towards my laptop? What about towards my mobile phone? What about towards my pen? What about towards my perfume? What about towards my clothing and everything? So I cannot store. Maybe I can store it. Whatever you can consider, you are describing the matrix in a way like the sparse matrices, the large matrices. You are describing it, but still, how much you can describe? Like, sometimes you like to drink. Let's say sometimes you like to drink 7 Up. Sometimes you like to drink Coca-Cola. How will you describe it in the form of emotions? So you can say, okay, maybe you can discretize it, like, afternoon I like to have the 7 Up, and in the evening I like to have the Coca-Cola. Okay, but what for now? Like, if someone offer you cold drink in the middle time of this or after midnight, what will you say? What will you like? Either you have to describe it. So if you are describing each and every moment, that means you are making the you are making your matrix a large and the large one. Hmm, you talk about something. The third question. Sorry for, like, Mohammed Murta. I guess I've commented on your text. Uh, Sarim Faruqi is saying you talk about something like resolution 108 something. Could you mention that again? Okay. I'm just mentioning it again. Let's say my presentation is visible to all of you, I guess, up till now. Yeah. Let's say for this picture, this is a resolution. You can see the number of rows here are 8, and the number of columns here are also 8. So this is basically 8 by 8 number of resolution. So similarly, if I just reconvert this image, the whole image, to the resolution part in a matrix form, so the order of the matrix will describe the number of resolution. So you can see here, like, the zoom in of this matrix is basic. The zoom in of this part is only shown by this way. So this is, like, you can say we have different shades here for, like, black, white, gray, dark gray, in different way, and these shades are given a weighted, like 64, 2, 3, 61, 60, and so on. So this is basically the matrix representation, but this is basically this is just because of the resolution that is being shown. Is it okay, Sari? Is my statement correct? Yep, Murtuza, your statement is correct, but you have to store the discretized form of the emotions and everything. Emotions, literally, this is a big task to store the emotions. you can describe the behavior, you can describe everything, but storing the emotions, that what is coming in your mind, what is going on in your mind, is so much difficult to store it. Like, let's say if I give you some task to solve the question, let's say a simple question. If I'm giving you a task like you have to solve 2 by 2 plus 2, okay, your mind will just give you an answer like 2 plus 2 is 4, fine. 2 plus 2 is 4, but that doesn't mean that your mind is totally focused and that 2 plus 2 to answer you. Your mind is also like, okay, the class is go on, like the time has been more than the promised time, like in 1 hour the session has been completed, I have to go to buy some grocery from that my mother wants or something else. The mind is continuously working. So storing the emotion and storing the behavior is so much difficult task for the AI. Sir, there is a myth. Kasim Alias Hasib is asking, sir, there is a myth among students that those who are good with mathematics will more likely to be better data scientists or machine learning engineers. What's your view on this? Obviously, if they are doing some inventions, if they want some inventions or new tasks to be performed, they should be very good in mathematics. But if they are just like using the pre-developed tools, that means that these pre-developed tools will not be like will be sufficient for all of you, but still you must have the a basic knowledge at least. This cannot be possible like the grocery vendor can understand the machine learning directly. So you have to understand the mathematics behind the working. But if you are good in mathematics, you'll be a great data scientist, and or you can understand the machine learning algorithm or machine algorithm and so on in a better way, and you can invent a new algorithm also. You can invent the many things. What is the importance of eigenvalues and eigenvectors? Eigenvalues and eigenvectors, okay. Let's see. Let me show you a whiteboard. So whiteboard.
I think there is a activity option below.
Oh, yeah, yeah. Mm, okay, I've shared the whiteboard to you. Like, what are the eigenvalues? You remember? Like, you are describing it as a minus lambda I of matrix X is equals to 0. Fine, but let's come up on its back. Like, let's say if I have only A that is equals to X, and if I just subtract this matrix A minus X equals to 0, so I must have some values that can be equal to A equal to lambda X, sorry. Now in this matrix, in this form, like what is going to happen, like this matrix is represented by only a number. Now X can be transformed, X can be any matrix, X can be a column matrix or any other matrix. But like, let's say, if you have two matrices, 2, 3, 4, 5, and you have to multiply it to another matrix, 3, 5, 6, 8, it will take time, at least a time that is more than to calculate it through, like if you just have to multiply a scalar number. तो अगर स्केलर नंबर मल्टीप्लाई करना है, it will take a less time than to multiply with the two matrices. Okay, so what you are going to show here, like we are considering the eigenvalues, like we are finding the eigenvalues that are equivalent to that matrix, that can be represented by that matrix. So we are compromising with the resolution of the result, but the result is like equal, it's totally equal. So by using the eigenvalues or by using the eigenmetrics, you can store the data in an efficient form. You can perform the next task in an efficient form. But we have to compromise the resolution in that task. Okay, just this is the working of the eigenvalues. Where are the questions gone? Okay. Can LA be used for Caesar cipher? LA, for simple ciphering, LA is used. For Caesar cipher, there is a part, only a part that can be used in LA, or LA. But simple Caesar cipher. What do you mean by Caesar cipher, Asadullah? Like which part do you want to understand in the Caesar ciphering?
सर आई गेस सीधा शिफ्ट होता है ना, जिसमें
लाइक
उसमें
उसमें
एक ऐड
कौन
कर
सा
देते
पार्ट
हैं.
आप LA से कनेक्ट करना चाहते हैं? I don't get your question actually exactly, but although the LA is used in it. Last question: which language would you prefer to use LA applications? Basically, I'm not using the LA applications, although for so many things. Since I am a mathematician and I am currently doing research in computational field dynamics. So computational field dynamics has its own limitations. Like computational field dynamics can be discretized by using the finite difference method or finite element method and finite volume method. So you can ask me like which method for the discretization of a continuous data to a discrete data you are using. So I'm using the finite element method right now. So my research is basically related to the fluid dynamics. Encryption and frequency finger exploration. Yeah, finger part. Okay, that is basically the part in while doing the encryption. So this will be the matrix shift you are using basically. And for describing the matrix, uh, either you don't have the modulo in it, but still fine. While you're describing the matrix and while the performing the operations through the matrices, obviously you're using the linear algebra. For a big matrices, like you have to find the inverse or something, then this will be obviously you are using some of the algorithms of the linear algebra. Does linear algebra used in game programming? Oh, while right now for the game programming or something, you are using pre-developed softwares. So for that pre-developed softwares, I can say the linear algebra is used, but you cannot see it. आपको नजर नहीं आएगी कि कहाँ आप यूज कर रहे हैं. लेकिन अगर आप उसके बिल्कुल बेसिक के ऊपर जाएंगे कि लाइक हाउ इट वर्क्स, हाउ यू आर मूविंग द डाटा, लेट्स से in any games, let's say a car is moving, car racing game. सो कार रेसिंग गेम के अंदर आपने बहुत सारे रेफरेंसेस रखे हुए ना, बहुत सारे फ्रेम्स हैं उसके अंदर. तो उस फ्रेम को मूव करने के लिए आप क्या कर रहे हैं, आप वो कार तो अपनी उसी जगह पर है, वो फंक्शन वैसा का वैसे ही. You are just doing the scaling of the car, like you are just moving the car. So in this way, you are using it. But right now the game programming is basically working with pre-developed software, and these pre-developed software have so many mathematics inside, but you cannot see it. I guess this is all. So thank you once again for the management of FAST and Dr. Fahad and all the faculty members, especially the students to whom I have ruined your weekend for attending this session. I really appreciate. On a Saturday 9 a.m. Right now in Malaysia, it's 12 noon, and it's right now 1:15. But on a Saturday, you all are attending the session on 9 a.m. This is so mean for me, and I'll appreciate it. Thank you so much for all. Thank you.
Thank you, sir, for giving us so much information about the application of linear algebra. Hope students have learned a lot from your knowledge. So
Mhm.
we want to present some souvenir to you online. This is your souvenir we have, and we can send you in Malaysia, but we hope you will come back soon after your doctoral degree. And
Inshallah.
we also hope you will rejoin fast after your doctoral degree.
Inshallah. 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 We'll see. Thank you so
Thank you,
much.
sir.
Thank you all. Thank you all.
Thank you so much,
Assalamu
sir.
alaikum. Thank you.
Miss Alishba, Miss Uruj, Sir Shahid Ashraf, Sir Osama, All the faculty members are here and very much thankful to you.
Thank you so
Sir
much.
of the
Thank you so
classes,
much.
Dr. Usmani, Dr. Khosrow.
Thank you. Thank you.
Actually, I wish you all very good morning. We achieved an important milestone regarding application of linear algebra uh, in computer science. Actually, students are more just asking in the classes, what are the application? What are the application? Actually, we have very short semester, so we cannot
Yes, sir.
discuss,
As a
all in
teacher, I can
detail.
understand, like,
You know,
for while describing the session, while continuing with the course, it's very difficult to also discuss the applications.
that's why the seminar is very helpful for the student as well for us also. So I think we'll continue in the same. If you have time, then is it possible for
Inshallah,
you
inshallah, sir.
for the
Inshallah,
next
sir.
seminar next week or
Inshallah.
next after 1 month or maybe it's up to
Thank you
you.
so much. Yeah, yeah, that will be. We will plan it, inshallah, for any courses, for another other courses also.
Okay. Thank you, sir.
Thank you so much, sir. Thank you. Allah Hafiz. Allah Hafiz to all.
Thank you, sir.